All right, let's get started. So this talk is about bringing C# nullability into existing codes. If you're in the chat, it would be fantastic to see if you are using nullability already, if you're maybe using it while you're not aware that you're using this, or if you're not bothering updating existing code and so on. Whatever the premise or whatever your situation, the idea is that with this talk, I hope to at least convince you that there's value in adding nullability into your existing code bases. And also leave you with a couple of tips and hints on how you can get started with those, especially on existing code bases where it's oftentimes a little bit harder to introduce nullability properly. So let's dive in right away. Let's talk about nullable reference types in C# first. So let's set the stage and let's look at what will be the output of this code. Now, I know I don't have a live audience here, so I'll probably be a little bit quicker. But if you read through this code, you see that there's a console.writeLine that prints the length of a string by accessing a string.length property. And that string originates from a method called getValue, and that getValue method returns null. So what will be the output if you run this code? If you try this, you will see that there's a horrible, horrible null reference exception and that everything blows up because you're trying to access string.length property where the reference to that string is going to be null. There's no string to get the length from, so you will see this null reference exception. How do you solve that? Well, quite easy. You add a null check. So if you do that console.writeLine, you will check if that string is null or not. If it is not null, then you can print the length of that string. If it is null, you proceed like there's no string involved, and you just print something like string is null or whatever you want to put there. Easy, right? Except how do you know whether you need a check there? If you look on the right-hand side on the slides for value types, there's a compiler trick where, for example, for a date time or an integer or a Boolean and so on, you can add a question mark to the type, and the compiler will actually convert that into a nullable of t type under the hood. And when it does that, you will see, first of all, that the type is declared with that question mark, which denotes that it might be null at some point. It is nullable. But also it has a property .value to get the value of the datetime in this case, and a .hasValue, which kind of nudges you into doing a null check there, checking if there is actually a value in that object. And if it is, you can print the length or the value or whatever. If there's not, you can print something like, okay, no date was given and so on. With reference types, on the other hand, on the left-hand side here, you will see that you get no such hints. That string can either be null or not null. You never know unless you check. But how do you know whether you have to check? If you're really defensive about your code, you will check every single reference type for being potentially null or not. But that's obviously also not something you want to do, because if you're writing code, there's very often going to be cases where you just know that a particular reference type is never going to be null, because that's the way you coded it and that's the way you set up your code base, right? So how do you know whether you need a check? Well, with nullable reference types in C#, you can actually make that possible or a little bit more clear to anyone consuming your code, including yourself. Now, if you think of nullable reference types, the fact that they are nullable, those reference types, is actually something that has been a part of C# all along. Every reference type in the code base is nullable. However, with the introduction of nullable reference types and nullable annotations in C# 8, the idea was flipped around a little bit, where the idea is that when you're writing code, every single type that you have is going to be non-nullable by default. And there is a syntax to annotate a reference type as being nullable. A lot of compiler magic going on under the hood there, but ideally it flips the idea while writing codes. It flips that idea around where you have to be explicit about whether something can be null or cannot be null. So if you look at that and we take our previous example and we have that getValue method, you can add that question mark there and say string question mark means this getValue method can return a null value. And if you do that, you can safely return a null value there, and consumers of that getValue method will know if something is going to be null or not. So if you think about this, what will be the output of this code? It's also going to be a null reference exception. Again, object reference not set to an instance of an object. Your application will probably throw and die if it's the only thing that is in your code base there, because that getValue is still returning null, and you're still trying to access the string.length. However, if you are writing code, you will see that that snippet of code, this particular piece of code that we have there, will emit a number of compiler warnings. And also in the IDE, you will see some suggestions and inspections pop up that say that you're actually working with a nullable type and something that is very likely going to be null. So in this case, you will see that there is an error saying that converting the null literal or possible null value to a nullable type is going to be there. First line of the code there, where you say, okay, I have a string explicitly saying this cannot be null, and I'm assigning null to it, or potentially null, because get value potentially returns null in this case. So that's going to be the first warning you will see. But then also when accessing string.length or s.length in this case, you will see a warning saying dereference of a possible null reference, because S is going to be null at that point. And your IDE, again, will show those things as well. So you'll get nice squiggles saying, okay, you're actually attempting to read from a null reference in this case. They are, however, just annotations. As we've seen with that null reference exception in the two examples there, these are just annotations. It is giving you hints while you're writing your code, and it gives hints to the compiler. You can detect potential null values, but it's not that this safeguards you from never running into a null reference exception again. So it's only design time and compile time help that you get, where you will clearly see that you are working with something that can potentially be null and then be defensive about that thing. But also the opposite direction, if you know that something is never going to be null, you can also annotate it like that, or not annotate it, because then it's going to be non-nullable by default. But it means that the IDE and your compiler will know that, okay, in this code path, this reference type is considered to never going to contain null, so I'm not going to bother with warning you about what you're potentially doing there. The way this all works is by flow analysis. So the compiler and the IDE will go through your code and then figure out, like, okay, what is going on there with this particular piece of code. And to demonstrate that, I'm actually going to drop into the IDE. And I know previous talks on this conference had a bit of a promo for the Islands theme, which looks fantastic. But also you can add a nice background to your IDE, and that also looks nice. Anyway, flow analysis. I have a piece of code here where nullable reference types are enabled. And you will see, first of all, that with the example that I had previously on the slides, here you will see that get value is potentially returning a null value. So I want to work with that. And also here, this thing is potentially returning null, and I'm accessing this null value. So you see all those squiggles basically because the compiler and the IDE determine that something can be null. Now, interestingly, if I change this and remove that question mark, you will see all of the squiggles change all of a sudden, because all of a sudden I'm saying this get value method can never return null. So all the previous warnings will go away, because I'm now telling the IDE and the compiler, like, look, this get value method is never going to be null. So the flow here is going to consider S as never being null. However, we now get a warning saying, okay, you're returning null there, which is not something you want to do there. And also there you will see that I can either change the type of my local function again to string question mark and make it nullable, but then you will see the flow analysis analyze the other bits of the codes again as something that's potentially wrong. Or I can lie to the compiler and say, okay, exclamation mark, and basically say, okay, ignore this null check and consider this as not being null. And if I now do something like this, all of my code looks good. So again, the compiler and the IDE will figure out what is the flow of everything that is going on here. I have another example here, var. Var is actually a way of declaring a reference type or reference to an object where you never know whether something is going to be null or not. The reason for that is that while you might assign an actual value, an actual reference to this string, like in this case where we say, okay, this is going to be an empty string, at a later point, you might set it to null. So if this is the case, we're still going to have this nullability warning and say, okay, you're potentially dereferencing a null value there. However, if I do a null check there and I say, okay, string is null or empty, and then return, I will see, sorry, like this, I will see that this also goes away. So again, flow analysis figures out that by doing a null check, I'm actually safeguarding the code below that check from potentially looking at a null value there. So the compiler and the IDE are relatively smart about this, and they will give you good hints about what is going on in the code that you're writing. All right, back to slides. So flow analysis is the IDE and the compiler analyzing your code flow, looking at all of the code paths, determining whether it should show a warning, multiple warnings, no warning, whatever. It will basically go through things, and based on how you write your code, on how the code is structured and so on, you will see that you will get different warnings or no warnings at all. var is always considered nullable, again, because you're writing code where you never know whether later in a code path, for example, you're going to assign null to that var, so you never know, unless flow analysis determines otherwise, where the var is never assigned a null value. It's always going to complain and say, hey, this might potentially be null, and give you warnings there. The null coalescing or the null forgiving operator, this exclamation mark that I added there, or the dammit operator from the talk title, that is used to suppress warnings. So if you don't want to have a nullability warning and you just want to say, okay, null is fine here, I know what I'm doing, exclamation mark, I know what I'm doing, you can actually say, look, compiler, look, IDE, I know better. I will steer you into not giving any warnings and so on. I would highly advise you against using this exclamation mark or this null forgiving operator, because you're actually lying to the compiler. You're lying to yourself when you are working in this code base a couple of months after you first wrote the code. So consider it an anti-pattern. It is, however, quite useful, and you're migrating to nullable reference types, where sometimes you might want to have this just to suppress a couple of warnings while you are working on the code. But ideally, your code should not have suppressions. So in summary, again, no runtime safety for nullable reference types. It is design time and compile time help to check whether something can be null or not when you try to access it. And it gives you better analysis of your code. So your null checks will help the flow analysis. The compiler will figure out how things are structured and so on. But again, no runtime safety, only design time and compile time safety. The dammit operator, use it if you really need to, but again, consider it an anti-pattern, so don't use it if you don't have to use it, and there's other ways around. All right, now, how do you surface nullable reference types in your project? Depends on how you want to surface nullable reference types in your projects. There's the nullable annotation context, where you can actually say per file or per class or even per line of code, you can add a pragma or a nullable with enabled or disabled in code, where you can enable or disable nullability per line of code, even if you want, or you can enable or disable this in the project file and enable it project-wide or disable it project-wide. In newer .NET versions, you will always see that it is enabled by default, or in newer C# versions, actually, you will see that it's enabled by default. In older versions, you might want to set this either per project or per file or whatever you want to do there. There's a number of potential values that you can put in there. You can disable this behavior. So just basically disable nullable reference types. You will not get the warnings. You will not get the flow analysis and all of those things. You can enable, which will give you all the bells and whistles, all of the analysis, all of the language features around this, etc. There's two other options as well, warnings and annotations, where you can pick whether you just want to see the warnings or whether you want to be able to write those question marks and so on without compiler errors, but not care about any of the warnings or any of the nullability analysis. Typically, you'll end up using either disable or enable. And in this talk, I'm advocating to always enable. Warnings and annotations might be useful, but to be fair, I've never seen this one being used in the wild very often. So in summary, that nullable annotation context is basically giving you a toggle to surface or to decide what you want to surface in your project and in your IDE. And you can enable it by default or disable it by default. And as a tip, since the talk is about bringing nullability into your projects, I would say if you're building a new project, always enable it, keep the default, and just keep it enabled. For existing projects, you might want to disable it project-wide and then gradually add nullable enable in each file, so you can migrate file by file until everything is migrated over. All right, let's talk about annotating your code as well. Is that question mark actually enough when you start coding? If you look at this particular piece of code, and I'll give you some time to read it a little bit, you will see that this slugify method takes a string. If that string is not null, it will actually replace all of the spaces with a dash to make it URL friendly. So typically, if you're writing a blog, for example, using the slugify method, you can give it a title to your blog post, and then you will get a nice query string that, or a nice URL path that you can use in your code base. Now, is the question mark here enough? Good question. If you look at slugifying, this is fine, for example, you see that the response or the result of that function is still going to be potentially null. Reason for that is that we declared our slugify method as potentially returning null, right? So this is correct, and we're actually telling the IDE, look, anything that is returned from this method can be null, and the IDE and the compiler will work just fine, understand all of that, and give you a warning saying, okay, this is the reference of a possibly null reference. Now, if you look at that code and you start thinking, it actually returns a non-null string whenever a non-null parameter is passed in. And it will indeed return a null string when a null parameter is passed in. So is there a way to tell the compiler that this duality exists in this method? Well, there is. You can add fine-grained annotations and basically say, okay, the return value of this method is going to be not null if my parameter named value is not null. So adding this annotation is actually going to help the compiler and the IDE understands that, okay, whenever I pass in null, this is going to return potentially null. Whenever I pass in an actual value in that string, it is going to return a string that is not null that I can work with. And with this, we're actually helping flow analysis make better suggestions, make better warnings and compiler warnings and so on. So if you do it like this, you will see that on that first example where I pass in null, you will actually get a warning saying, okay, slug1 can be a null value. Whereas if you pass in a value, you will see that the second line of code or the second slug that we're generating there is going to not throw or not potentially dereference a null value there. There's a lot of those fine-grained annotations. If you look into the .NET base class library or the C# base class library, you'll find is null or empty on a string. And that method is actually going to annotate not null when false. This is a bit of a strange construct, I would say, but that's the way the compiler goes through your code and so on. But what you're doing here is you're saying if this method returns false, the value parameter to this function is going to be non-null. So in the example where you have a string that is null and you do an if string dot is null or empty of that value and so on, you can actually see that the compiler and the flow analysis uses this annotation to determine after that check whether that value can be null or not. So by saying, okay, when this returns false, my value is never going to be null. Which is quite nice because if you do something like this, where you have a string that can potentially be null or potentially an empty string, you will see that that first console.write line where we access the string.length will still say, okay, look, this is potentially null. But if we do then a string that is null or empty as a null check, the line after is just going to let us access the length property there because we actually checked whether this can be null. And because we annotated this method as being not null when the return value is false, this is not going to throw a warning or show a warning or any of those things. Cool. There's a lot of those fine-grained annotations. There's a number of preconditions where you can annotate a different behavior when writing to a parameter or a field or a property setter. There's post conditions, which apply when reading from a field or a property or return value. Conditional post conditions, where you can do something where you say, okay, if this thing returns false, then this thing is not going to be null, things like that. And also failure conditions, where you can just say, okay, whenever you hit this piece of code, don't bother with further analysis because I'm going to throw an exception or this thing is going to stop the application or whatever. So you can just stop analyzing. That's also an annotation that you can add there. I'll say, have a look at the Microsoft Learn documentation there. It's pretty good with lots of examples, but just to give you a couple of ideas of what you can do there, I'll jump into code for a second and give you a bit of an idea of what you can do. All right, annotating codes. In terms of preconditions, there is an option to say, I want to allow null input for a specific property. So if you look at this person class, for example, it has a username where the username by default is going to be a new GUID. If I get the username, this means that the username is never going to be null, and I can safely say, okay, this is going to return a non-nullable string. However, I will still allow setting null, which means that when I set null, I'm going to simply put in a new GUID as the username. The nice thing there is that when I now use this person, and even when I set this username to be null, I'm never going to get a nullability warning whenever I try to dereference that username. So when I want to use the link there, for example, you will see that there's never going to be a nullable warning, because we are telling the compiler, look, I allow setting null, but the getter is always going to adhere to whatever I declared this property or methods as. There's also the inverse, where you can say disallow null, for example, where now setting this null value is going to be disallowed, but I can still get a null value. So this thing should also, in fact, return a nullability warning there. Post conditions, kind of similar, where you can say, okay, the middle name of a person, not everyone has a middle name, it may be null. So if you query this, if you access this thing, this can be null. However, when you set the value, it should never be null. So that means when I start using this middle name property, whenever I try to assign null into that middle name, you will see that I'm not allowed to set null there. However, when I access the middle name, I should get a warning saying that, okay, this thing might be null. So you now get that warning there. Conditional post conditions are the more interesting thing, I think. With that is valid username or is null or empty and so on, that not null when annotation is pretty nice, because there you can say, okay, if this method returns true, then username is not going to be null. So this means that if I now do this person.isValid username check, I know that length is never going to be null. However, if it's not a valid username, I cannot guarantee that username is not null, and I will give you a warning saying, okay, this thing can be null. Couple of interesting helpers there as well. This is one that I particularly like, where you can delegate to a different property or methods a null check on another property or method in a class. So to give you an example there, we have a person where a check for has location will basically tell the compiler and tell the IDE that location is not going to be null. If there's no location, it can be null. So you'll see the warnings there show up when has location is null in this case. The way this works is by annotating with member not null when, where we say, okay, the member location is not going to be null when this thing returns true. Again, a little bit backwards, but you get the idea. You can annotate and help the compiler in figuring out what this has location method does and what querying it means for the rest of the flow analysis, in this case, accessing the location of that person. All right, and then failure conditions, I can show you. There's, for example, an annotation does not return, where you can actually say, okay, this thing does not return, and then based on that, you will see that the compiler will never analyze the lines afterwards, after that line of code, because it's never going to return. But I'll leave that one as homework for this session to explore when you're back home. All right. There's compiler annotations, but there's also the JetBrains annotations. I know Microsoft has all of these compiler annotations in the source code and so on. JetBrains actually had annotations or annotation attributes way before. And many libraries actually ship them. So if you look at Entity Framework Core, for example, still today, they ship JetBrains annotations to make the flow analysis in ReSharper and Rider slightly better and a little bit more powerful. So if you're lucky and you're migrating a code base and you have JetBrains annotations, for example, in your own code base or in a library that you're consuming, you actually get all of those hints, of course, when you're using ReSharper and Rider. But you will get those hints that will help you figure out, okay, what's the nullability status or what's the nullability contract with this particular method or property or variable and so on. So there's a number of those. I actually like the contract annotation there a lot, because the syntax is a little bit easier than that not null when that the C# team shipped, where you can just say, okay, if the JSON is null, then this is going to return false. So it reads a little bit nicer, but you're lucky if you're consuming anything that uses JetBrains annotations, you will also get the help or the nullability assistance from the IDE there as well. One thing we haven't seen yet is nullability and generics. With generics, it's quite simple. If you want to declare or if you want to create a new variable there, use the question mark where needed. So in this example, we have a non-nullable list of non-nullable strings. Second line there is a non-nullable list of nullable strings. So this list can contain null strings. And then the last line there is a nullable list of nullable strings, which means that the list can be null, but also any element in that list can be null. So again, use the question mark where needed. Compiler will figure out what's going on with the types you're trying to access. If you're writing methods that use generics, you can also use those annotations where you can say, look, if you want to find something using a predicate in a particular enumerable, you can tell the compiler that the result may be null, for example. So you can annotate that by saying, okay, this result of this find method can be null or cannot be null in some cases. You can also use the not null constraint, where if you write a generic method and you accept a generic type as a parameter, you can actually say, okay, that type should not be null, which means that if you say write to console, for example, and pass in null, it will actually give you a compiler warning saying, okay, this does not match that not null constraint that you have there. All right, referenced codes, libraries, and frameworks. Using and migrating to nullable reference types is relatively straightforward if all of your dependencies are using it. Good news, for a couple of .NET and C# versions now, all of the base class libraries are annotated, and many open source libraries are annotated, but of course not all of them. I would say it's a good practice to always annotate your own code for dependents. So if you're building an in-house framework, for example, at least make sure that the API surface that others in your company or others in your team are going to be using is annotated, so they know and get design time and compile time hints about nullability there. Ideally, your entire code base, but typically the public API surface is enough to at least help whoever is consuming the libraries that you're writing. And again, remember, nullable reference types are not runtime safety. So if you are shipping a library, yes, you want to annotate it because you want to make sure that people get the right hints when consuming things and writing code and working in the IDE and so on. But also there, you might want to consider still adding null checks for that code, because others might call the code without ignoring all of the nullable reference type annotations. They might just pass in null where you don't expect null. So if that is a potentially destructive or failure condition in your application codes, that is something where you still want to do a null check, even with nullable reference types. Also good to note is that nullable reference types are C# only, which means if you're using F# or VB.NET and so on, nobody will get those annotations or the design time help there. So you still want to have the null checks for runtime safety. So in summary of this section, I would say there are more annotations than just that question mark. Use them because they can clearly communicate the intent of what you're trying to do in your codes with the compiler, with the IDE, and so on. There's compiler annotations that are good. There's JetBrains annotations if you're using JetBrains IDEs. And if you're shipping codes that is consumed by others, you may still want to add null checks for your libraries just to make sure that you don't end up in a failure condition in codes. All right. This talk was about migrating to using C# nullability. So let's look at some techniques and tools that you can use to upgrade your C# project. This one we already kind of covered, where the default nullable annotation context is one that you can set at the project level, at the file level, or even at the line level or the method level if you want to. For new projects, I would say go with the defaults of modern.NET and enable it. For existing projects, I would say if the project is small enough, just annotate or enable project-wide and then plow through, fix all of the things that you run into. For larger projects, following the Boy Scout rule, as it is called, is probably a good idea, where you keep it disabled at the project level, and whenever you touch a piece of code, you enable it file by file and just work your way through until the entire project is converted. You might want to add warnings at the project level if you want to do this in a CI scenario, for example, just to get an idea of where you are in the migration. But generally, if the project is sufficiently large, I would say do it file by file. And in the end, you will be in a place where you get good information about nullability. Start at the center and work outwards. I found that when you are migrating, when you are trying to convert an existing code base to use nullability, classes that have few or zero dependencies on other classes are typically the best ones to start working with. So very often, data transfer objects, plain old CLR objects, the data transfer objects that you have in your code base are going to be perfect candidates, because very often they don't have references on other types or zero dependencies on other types, but they are being used by a lot of code in your code base. So if you have a person class, for example, and all of a sudden you can tell the compiler the first name and the last name are never going to be null, that opens up a lot of checks or a lot of warnings that go away, because all of a sudden the compiler knows at every call site, every usage site, that these things are not going to be null. So a small change in one of those types of objects might flow to many places. How do you find that? I have a diagram here. The actual contents don't matter that much, but you will find in ReSharper, in Writer, in Visual Studio with tools like ndepend, you will find that there's type hierarchy diagrams that you can use to analyze your entire project. And you want to find namespaces or groups of classes where most, if not all, of the arrows are incoming. So all of the codes in this code base is depending on models, or everything that is in the folder models. So everything in that folder is great to start with, because that's going to flow through to a lot of places in your code base. Same thing if you look at the class diagram there in that models namespace, you will also see that there's a lot of arrows coming into person and course. So those two classes are probably good places to start with adding nullable reference types and enabling nullability on those things. For each class, you can enable nullable reference types by adding nullable enable at the top. And then for every property and constructor parameter, you typically want to find all places where you're writing to that property or to that constructor. If you see it's potentially set to null, you can annotate with a question mark. If it's never set to null in any place you can find, then you're good, because you don't have to add an annotation there, and you can consider that as non-nullable. So let's see how that would work in real life. I have a class called location info here, and this is actually from an existing code base where that location info is used to determine, based on an IP address, where you live in terms of country and in terms of location. Could be city, could be town, could be whatever. That is used by a method get from IP address, which checks a specific database of IP addresses and so on, tries to get the city and the country, and then based on that will return a new location info. So straightforward, typical code that you might see in a class. So how do you go about converting this to nullable? First of all, you want to enable nullability there. It's enabled by default, so you will see this is now grayed out, so I can even remove that. And then we can start working. Previously, because we didn't have nullability enabled, country and location could be null, which means now we actually said, okay, country and location can no longer be null by simply enabling nullability. So we want to check if that is really true. How do you do that? Well, you can find usages for a country, for example, and look at all of the right usages. Where is this country being set, and is any of those potentially null? It's being set in the constructor, apparently. For my location, I can find the same thing also set in the constructor. So I don't get all of the information here, so I go to the next level. I want to find, okay, where is this location info instantiated? Look at the results there, see if I have a place where there's potentially null being passed in. And apparently, yes, because my results.country.name can be null, and my city.name can also be null. So in this case, I know that my location info actually, based on usage, accepts a nullable country and a nullable location. When you are migrating, this is actually also a really good opportunity to think about the code that you're writing. Because if I open up this string or this country and this location to be nullable all of a sudden, this means that throughout my entire code base, if this would be used in 100 locations throughout my entire code base, all of a sudden, by doing this, I'm forcing my code base to check for null. If I already have those 100 null checks, for example, by doing something like this, where I can actually guarantee that this is never going to be null, I can potentially remove those null checks. So it is a good opportunity to think about this location info and maybe even rewrite the code a little bit. So I only had one usage where I was potentially passing in null. So maybe I want to return something where location info when country.name or city.name is going to be location info.unknown or something like that, and no longer pass around a null value. So what I could do here is say, okay, if result.country equals null or result.city equals null, return location info unknown. And you will now see, right. Anyway, you should now see that, I should check the name there. Yes, there we go. We now updated our code to be null safe, or at least at design time and at compile time, because I'm now always passing around location info. Location info is now always going to contain a country and a location, and I can use this throughout my code base. So going through this, there's a couple of things you want to check. Am I setting null? Am I not setting null? But also you want to check whether you might potentially want to rewrite part of your code base to be more null safe at runtime as well. All right. So basically, when you start annotating, you might want to redesign as well. Sometimes that actually makes sense. Nullable annotations also surface through your code base, much like async await. So that means if you add a nullable question mark when migrating, are you introducing checks at every current and future usage of that particular property or not? Maybe you want to just do that check once and return a null object or something like in this location info example that we had there. It's going to depend on the use case, and I will leave it to your judgment on what you want to do there, but it's good to consider, do I actually want to annotate this thing with a question mark there or not? Suppressions. We already talked about suppressions. If you have an exclamation mark somewhere in your code, you should not ship that code, or at least to fellow developers that are using it, because you're lying to the compiler. In Rider or in ReSharper, for example, you can actually find nullable warning suppressions and remove all of them. It can actually be useful when you're migrating, but I would say the moment you think, okay, we're complete, check for those exclamation marks because you want to remove them from your code base. One thing with this talk, don't be afraid of null. I'm saying null is bad, but that's actually not the main message or not the message of this talk at all. Don't be afraid of null. Nullable reference types will help you get more confidence into compiler and IDE flow analysis. It's impossible to get rid of all of the null usages in code, especially with third-party libraries and so on. That's not the goal of this, but you want to build a safety net for dealing with null. Have your developers and yourself know that some things can be null, some things are almost guaranteed or fully guaranteed to never be null, because it actually helps them in writing code, and you're reducing the chance of unexpected null reference exceptions. If there's an unexpected one, that's fine, but at least with annotations, you will know when to expect a potential null reference exception if you are building your code. So in terms of techniques, always enable nullable reference types for new projects, start at the center and work outwards, annotate, redesign if needed, suppressions are temporary, and don't be afraid of null. Right, a couple of tools that can help, and that's going to be the last section, I promise. I can keep talking, but I promise. One very useful tool in Visual Studio, in Rider and ReSharper is value tracking. In here, I was going through my property country, seeing where this was set and so on. I can actually inspect value origin and see where my country is being set, and I can see the entire call stack there with all of the usages. So that's a very helpful tool to figure out, okay, how is this country being written to and who is setting it and where is this being used in my entire code base. So very, very helpful one. If you have JetBrains annotations and you're using the JetBrains IDEs, you can say, okay, use type annotation syntax after you do an Alt-Enter. That's quite helpful to convert to compiler annotations if you want to do that. There's an automatic migration in the IDEs as well, where you can migrate to nullable enable for a project, for a file, for a solution, and so on. It works quite well because it just runs the flow analysis, and then based on that, we'll see, do I need to annotate or not? It's not a silver bullet. It's not going to do everything right for your entire solution, but it will get you quite far along the way by just doing this and following the truth of your code basically. If you look at your code, you will also find that there's very often places where you can infer from existing null checks what the annotation should be. So if you look at this code where we are reading a column from a CSV file, you will see that the column name is currently annotated as being non-nullable. But is that actually true? Should we annotate this or not? Apparently, first line we have in that method, we are checking column name for null. If it is null, we return a default value. If it's not null, we work with mappings, with data, and so on. So ideally, here we want to annotate because apparently the code was written to support both a null value and a non-null value. Of course, you want to analyze the usage of this read column method, whether you're actually passing in a null value or not, because it can simplify your code. But at least based on this, we can see whether for this case we need to annotate or not. Third-party libraries, a lot of them are annotated, fantastic. However, many are not. So ideally, you want to assume null everywhere. Now, I know you will get depressed doing that because that might be a lot of cases. You can actually use pessimistic analysis in ReSharper and Writer to find all of those cases. I will say enable it and weep, because this will give you a lot of places where you will have to add a null check, but it can actually help you find places where you didn't even consider adding a null check. So if you're really serious about this, try pessimistic analysis. Probably don't want to keep it on continuously, but it's a good way to find out those cases where you might want to annotate. Two more things I want to talk about. One is JSON. How do you go about this warning? Where you have JSON, where you are consuming and writing JSON and so on, what do you do with this one? We have a non-nullable property name. We expect name, but we're not setting a value because we're always using a JSON deserializer to populate this object. What can you do? Well, several options. One is to mark it as nullable, but that means you lose all of the nullability information, and that's in every call site in your code, you will have to do a null check for that name property that is there. You can lie to the compiler and just say, okay, name is initialized with null, exclamation mark, basically say, okay, compiler, treat this as non-null, even if it is. It's an anti-pattern because if you do something outside of your JSON serializer with this object, you might run into unexpected null reference exceptions accessing that name property. Another option is adding a default where you say, okay, the name is unknown. That's a good alternative, up to you. You can also go all in with annotations and say, okay, I want to allow setting null and then have that default value and so on. I would say if this is something you like building, go for it, but it's also cumbersome and it's not really adding a lot of value. One way to go about this that I can recommend, and that is my personal favorite, is adding the required keyword there and just say, okay, the name is always going to be there. I require this to be there. However, if you're reading from JSON, that data that you're reading might still be null. So if you're using system.net.text.json, you have an interface called iJSON on deserialized, where you can actually check for null when reading that JSON. Or you want to use a mapping type of approach where you don't pollute your domain model in your application with inputs that might contain null values and so on. So a couple of options there. Last thing I want to cover is entity framework. I will just leave you with a warning there. The idea of nullable reference types is that it should never, ever, ever affect the outcome of what a certain library is doing and so on. Entity framework core team, unfortunately, did look at this, and they are actually updating your database schema based on nullable reference types. So if all of a sudden you say a person.name can be null or cannot be null, your schema is going to change as well, which might be unexpected. So if you have entity framework core, definitely look at it. Make sure that you are a little bit more careful. It's actually quite useful and it makes sense. So I understand why the entity framework core team did it, but it might be a surprise if you do bulk conversions to nullable reference types. So in summary, lots of tools available. Value tracking is super helpful. Converting JetBrains annotations to C# nullable annotations as well. There's automatic migrations tools. If you read your code, you can actually very often figure out, okay, do I need a null or a question mark to annotate this type or not? And third-party libraries, well, be careful with JSON, consider mapping. And if you're using Entity Framework Core, also consider double checking that there's no schema changes that you did not expect. So in summary, nullable reference types give you design time and compile time safety in .NET, not at runtime. Nullable annotation context can give you a specific level of help. I would just say enable it always so you get all of the help. You can add multiple annotations to communicate the intent with the compiler. Null is fine if you know where, so don't fear null. It's actually quite good. The null forgiving operator is an anti-pattern. Keep that especially in mind. And there's lots of tools and techniques to migrate, like start from the center, look at value origin, for example, to figure out how to convert something or where something is set to potentially null. With that, thank you. If you want to read more, if you want to find out how to do this, I actually have a written version of this talk available as well. So feel free to explore. And if there's any questions, I'm happy to take them.
Yeah, hey Maarten, that was a fantastic talk. Thank you. It's surprising how there's such a sort of long tail on this topic. Really, you kind of it's like yeah, C# Nullable. I know C# Nullable. And it's like, oh yeah, hang on, you've got so much legacy code sitting around that migrating it can be painful. So it's yes. And the entity framework. That warning about entity framework, I didn't know that one. That's a nasty gotcha, isn't it?
Yeah.
Definitely a gotcha, yeah. And it depends if it's the dev team maintaining the database, then that's usually going to slip through the cracks. But if you have a DBA who will get angry and yell at you because you are making schema changes, that might not be something you want to have.
They like to yell. Yeah.
It's part of the job description for a DBA. It's like, can you yell at people? It's like,
right.
That's mean, and I take it back. I love DBAs. They're lovely people.
Yes, but that's still true. Anyway.
You're going to get in trouble, Rachel.
Like that ship has sailed years ago.
This is really clickbait. Someone is going to put this on social media and say, "Hey, come look at this JetBrains stream because they're talking about DBAs and bad ways."
They're trashing DBAs.
Okay, let's try our best and let's pull it back on course then, shall we?
So that long tail. So before C#8, we didn't have this nullable reference types. It's almost like there's this big history of nulls causing a problem and maybe costing a lot of money and expense. Anything you have to elaborate on that?
I mean, very often those code bases have been around for a long time already and have been tested. All of the null reference cases have been ran into, and there is already defensive measures in doing null checks and so on. So it might be that an older code base is actually perfectly fine without nullable reference types. However, you still want to annotate at some point because it can help new developers on the team, yourself, 5 years from now as well, to figure out, okay, is this some place where in this new code that I'm writing, I can expect a null value or not? Should I add a null check or not?
Yeah, and wasn't there a quote from somebody about nullables costing like $1 billion? I forget exactly.
The $1 billion mistake, yeah.
The $1 billion mistake.
Yeah, so
I think there's languages where null isn't as prevalent as in C#, for example. I think in C#, in the paradigm that C# covers, it's fine to have null, and though some people swear by value objects or null objects where you return something like that location info dot unknown or something like that. But I think in C# it's fine as long as you realize that you actually want to build a safety net and communicate with your fellow developers with the compiler. That something is potentially null.
Yeah, I was actually going to ask you about other languages, because I know funnily enough, you're familiar with Kotlin, which has got null safety sort of built in a very similar style. In a way, you can have nullable reference types and non-nullable reference types. But you've got something like the val keyword instead of the var. What do you kind of how do you see the two of them together? Do you see any differences between the two, really?
They are very similar in a way, at least in terms of how you use the tools in the language and so on. I think with all of the new keywords like required, like the fact that you can have init properties, for example, where you say, okay, this thing is going to be read-only, so if it's non-null, you can never change this thing to being null and so on. I think C# added a lot of things that Kotlin, for example, is also providing there, albeit Kotlin is a little bit more concise to define all of those. But it's actually good to see all of those things come around because like you saw, if you have a property where you say, okay, this property is returning null exclamation mark, you're actually lying to the compiler. If you want to do that in Kotlin, I think last time I tried it, it is possible, but it's very, very cumbersome. And I think that's a good thing because it actually forces you to think about nullability. Whereas in C#, it is all too easy to basically lie to the compiler and trick your fellow developers.
Which is never a good thing.
Yes.
Yeah.
Yeah.
Because I was thinking about this when you were talking about var and how var is always nullable, and it's like, oh yeah, but Kotlin's got the val keyword, which is kind of nice. Why is var always nullable?
Because so if you declare, for example, a string where you say, okay, I have a non-nullable string, you're actually telling the compiler that every usage of that string is, or whenever you assign a value to that string or read from that string or whatever, you're actually telling the compiler this is non-nullable, period, non-negotiable. However, with var, because the compiler is supposed to infer whether something is going to be nullable or non-nullable, the fact that that var can be null or not is going to depend on the flow analysis. So it's going to look at the entire flow of how you're building your code and so on. So it is good to consider var as always being potentially nullable, because based on how you are using that variable, it might be that you're putting null in there or making a null reference there.
Yeah, because you can always reassign var.
Yeah, exactly. You can reassign a var. If you reassign that explicitly declared string that is non-nullable, you are going to get a warning where the compiler yells at you and says, hey, you said this was never going to be null, and now you're assigning a null value to this. That's not how it's supposed to work. If you do that with var, compiler is going to be happy, flow analysis is going to be happy, just the flow changes.
I'm glad you brought up that the null forgiving operator is an anti-pattern. I see people liberally sprinkling this through their code, or you get the folks who are like, all right, we want to like update and use modern features and enable nullable. And then they go, wow, I got 7,462 warnings. Let's just question mark everywhere.
Yeah.
You didn't have the upgrade. You didn't have to use that feature. There are nice ways to mitigate it, as you explained here. So
yeah, exactly. And I would also say if you're migrating and you have 7,000 or 19,000 or 900,000 warnings, just stop it and do it file by file.
yeah.
You won't survive tackling all of them in one go.
Right.
We did have a comment on the chat really asking about that. Instead of adding null directive gradually, it's why not just put it across the whole file and make everything nullable ? Is and then trying to fix it up. Is that an optional strategy? It feels a little.
It is an optional strategy. It is indeed painful, I would say, because you actually have to update all of those things. You can probably automate a little bit of that, and that's going to work. Yeah, it's an approach. Let's leave it at that.
Okay, not something you'd recommend then, I guess.
I mean, I'm not against it, but I also think there's not a lot of value versus just doing it gradually and keeping it as is.
Do you think nullability is viral, like the way async await is? So if you make a change in one file to make it nullable ready, is it as viral and intrusive as async await can be?
In a way, yes. So if you have in that location info example, for example, or if you have a person.name and you make all of a sudden the name becomes nullable explicitly by annotating it, that means that every usage of that name is going to all of a sudden require a null check because you said, okay, this thing can be null. So you will need a null check at all of those call sites. But potentially, if you have a class that uses that and then exposes another property that is derived from the name and so on, that's also going to be viral, and you will need null checks for that thing as well. So it is viral in a way, yes.
Okay. And I guess a follow-on from that one is how effective is it to be able to migrate part of a project? So if some of your project is nullable aware and some of it is not nullable, how do you know, and how can you rely on what the compiler is telling you?
I think a lot of that boils down to how stable is the project. Like if you have a very high velocity project where lots of things change all the time, then trusting the nullability is going to be hard if you only have like 10% of your nullability in your code base covered. However, if you have a very slow moving project and you know, okay, we're building this new module, this new feature, and we're just going to annotate everything there and add proper null checks for everything that is older that we are consuming, then you can rely on the fact that everything in that new namespace or everything in that new module, for example, is going to be annotated and more trustworthy.
Yeah, I like the Boy Scout rule you mentioned. Whenever you make a change in one file,
Yeah.
it's like quickly just change it into be nullable aware.
Yeah.
And you can actually start migrating that way.
Exactly.
Yeah. So a lot of this is centered on compiler and while we're coding. But what about your advice for null checks for runtime safety?
It depends. If you are in full control of your code, you do input validation, all of those things, then in theory, you have considered, okay, this thing will never be null, this thing can be null, and then based on the annotations, you can determine whether you need a null check or not. But that is if you are in full control of your code and nobody else is consuming your codes. If you're a library author, for example, and you want to make sure that people consuming your codes are actually getting good annotations so they get help while writing the codes, annotate all the way, but also make sure that you still do null checks when someone is using F#, for example, or someone is ignoring null checks and just goes like, yep, 20,000 warnings, I'll declare bankruptcy, I'll not care and just pass a null into this method. At that point, your library is still going to want to do a null check and make sure that the input passed in there is never going to be null.
Yeah, fair enough. I think we'll wrap it up there then. We've got one last question, though, from a caller called Matthias. He wants to know if you're going to be able to share your .memory demos with him next week at Azure Dev Summit.
I will do this. Perfect.
Oh, yeah. See you next week, Maarten.
Honestly.
I'll see you next week. Yep.
Thank you very much for your session, Maarten. It's very interesting. It's always a great technical session there. Thank you very much, and we'll see you soon.
Cool. Thanks for having me.